Prudent Scholars in association with Goa Headmasters Association.
Congratulations to each and every one of you. Now, you'll be wondering, why am I saying congratulations? And that is because if you are determined, to learn, no one can stop you. And the reason I'm telling you about this is only because in spite of all this pandemic situation that's going on, you're still in front of the screen watching this video to learn and to study mathematics. And that's the reason, I'm saying congratulations, because you are determined to learn. And if you give me your entire attention in this 40 minutes of time, trust me, you will be very good with this chapter. So let's start with it. Okay, I have a picture of Taj Mahal which I'm intending to print, okay, and I printed. Now, if you look at both these images, one on the screen and the other one on the computer, okay, the printed and the screen image, there is something similar and there is something different. So what are the things that we can look at? We can look at it in terms of shape and size. Now, if you just think about it and tell me, or you can answer to yourself that is the shape same? And you will say yes. But what about the size? Is there a difference in those size of the images? Yes, there is a difference. Let us take another example now. Okay, these are Patronus Towers in Malaysia, and if you look at it, is the shape same? Yes. But what about the size? Size is also same. Now, these are nothing but your real life examples. Let us take geographical images. Okay, so I have a geometric shape over here which is a square, one in orange, the other one in blue, and the shape is same. So instead of putting a tick mark, all I'm doing is putting a S, something like this, right? Sleeping S, so shape, okay, same. What about the size? Equal, right? Now wait a second, look at that symbol very carefully. You'll realize that that is a symbol that you have already studied in the 9th standard. And what is it of? It is of congruency, right? So the idea of having these shape is, if any geometric figure is same with regards to shape and it is equal with regards to size, then I will say that the figure is congruent. Again, it has to be same with shape and equal in size. Let us take another example. Okay, so I have two circles over here, and one in red, the other one in yellow. What about the shape? Same, right? What about its size? Now, size is different. So what I'll do is, when there is a change in the normal, I will not put any symbol. So here you don't have any sizes. So I will not put an equal to and a cancel there. So let's not write anything. And we are at a place where we have just the same kind of a symbol, which is nothing but similar. Okay? So when a geometric figure is same in its shape but different in size, it will be called as similar. Okay? So same with shape, different in size. Let us take another example, and I have two triangles over here, one in purple, the other one in green. So let's look at it in these two aspects with regards to shape and with regards to size. Now, is the shape same? Now you will say both of them are triangles. They look to be same, but they're still not same, right? Is because in the previous images that you have seen, I could just keep them on top of each other, and somewhere if you would stretch it, it would fill in that entire gap. But in this case, the triangles don't fit in like that. So shape is somewhat different. What about the size? Size is also different. So we are at a dilemma right now. So what exactly I should consider if I'm saying something is, similar? So that is what we are going to study in this entire chapter, which is chapter number 6, and it is triangles. Okay? And I'm sure you have studied triangles in the 9th standard as well. But here we are going to study little different things about it. Now, initially I had already told you that, give me 100% attention. You can give me, तुम अपने कान और आंख और नाक सब कुछ मुझे दे दे ठाकुर. Okay, so I want 100% attention from your side, because this is a chapter. If you are going to concentrate on something else, then you'll not be able to understand. So full 100% attention on the chapter, and don't bother about writing anything, because in case you want this information, my Instagram account, email ID is there. Please go ahead and send me one message. My YouTube channel is there. That's a link to that YouTube channel. You can just click a picture of that QR code right now and get in touch with me in case you don't understand something and you still want further clarification. Okay, because it should not be like I just teach it right now, you watch a video and you don't understand and you still can't do anything about it. I don't want that to happen. So you can get in touch with me on this email ID and my YouTube channel, and where I post videos continuously. There are so many videos on different mathematics chapters. In case, because the thing is, when I'm teaching it over here, I have a time constraint. I have to finish a certain part of a topic in that stipulated time. But when I have my YouTube channel, I can put up videos whenever I want. Whenever you communicate back to me that saying that you did not understand, I can have that much of time and liberty to put up another video for you. So please go ahead, and in case you want any further clarification. Okay, all these chapters, whatever we are talking about, are done there. Okay, so math world, that's where you have to go. Now, a triangle is basically made up of 3 sides and 3 angles. So total 6 ingredients required to make a triangle, right? So 3 sides, 3 angles. Same way, if I have another triangle, that triangle will also have 3 sides and 3 angles. Now, if I want to say, okay, let me give some names first. So I have a triangle ABC and PQR. Okay, now if I want to say that these 2 triangles are congruent, okay, so congruent, you already know the symbol, then something of this triangle, that is ABC, has to be equal to something of the other triangle PQR. And based on this only, we can say that these 2 triangles are congruent. So what is that information that you actually require? Okay, and based on these tests, which you have already studied, SAS test, ASA test, RHS test, and side test. Okay, so basically it is telling you that in the first case, SAS test, we are looking at 2 sides and 1 angle of one triangle is equal to 2 sides and 1 angle of the other triangle. If they are equal, then only I can say that the triangles are, congruent. Keep in mind that the angle has to be always in between those sides. Same way, ASA test would be 2 angles of one triangle are equal to 2 angles of other triangle, and the side in between those 2 angles are equal. Okay. Same way RHS test and side test is always when all the three sides of one triangle are equal to all the three sides of other triangle. Okay. This is all about congruency, which is just like a recap for you because you've already studied this in the 9th standard. The entire chapter was based on this. So what are we going to study in this chapter? We are going to see, so whenever two triangles ABC and PQR are considered similar, there are certain aspects that you have to look into to say that these two triangles are similar. So what are they? Corresponding angles are equal. Now please concentrate on the slides very carefully, okay? So what do we mean by corresponding angles? So here I'm saying that angle B is equal to angle Q. That's the meaning of corresponding. Now only one angle is required? No. You require all the three angles to be equal. Okay? So here angle C is equal to angle R. And angle A is equal to angle P. If three angles of one triangle are equal to three angles of the other triangle, then only I will say that these two triangles are similar. Okay? Now, three angles to be equal, is it compulsory? No. It can be two angles because you must have studied in your previous classes that sum of all the three angles of a triangle ends up to be 180 degrees, right? So if I have two angles of one triangle equal to two angles of the other triangle, by default the third angle will be equal. So in the course of chapter, we are not going to see this test as AAA similarity test, but we will only look at it as AA similarity test. So we just bother about two angles. So if at all with some information that we have, if we are able to prove that two angles of one triangle are equal to two angles of the other triangle, then I can say triangles are similar. Okay? And this test will be called as AA similarity test. Next, corresponding sides are in the same ratio. Again, concentrate on the slide because I want your full attention over here. So what is the meaning of corresponding sides are in the same ratio? First of all, whenever someone tells you a ratio, the word ratio is used, keep in mind that a ratio, imagine it, okay, that it's a fraction, okay, numerator upon denominator. Anytime, any problem, ratio is heard, think about it as numerator upon denominator. If you are able to picturize this, you will end up not making mistakes in the problem. So ratio means numerator upon denominator. Is that the only way of writing a ratio? No, there are many other ways, but keep in mind for understanding purpose, ratio numerator upon denominator. So what are we saying over here? Corresponding sides are in the same ratio, which means, okay, one side of one triangle upon one side of the other triangle, okay, is equal to something. What is it equal to? It is equal to, okay, one side of one triangle and the other side of the other triangle. Same way, it is also equal to this one. Okay, so corresponding sides are in the same ratio. Now, this will be called as side similarity test. Okay, now in this entire slide, that whatever you're studying right now, you will realize that if the ratios are equal, that means someone tells me that the corresponding ratios are equal like this, then I can say triangles are similar. If someone would tell me that triangles are similar, then the corresponding ratios are equal. So it works both the ways. Okay, so two things we have studied: AA similarity test and side similarity test. Okay, another third one which is important is a combination of these two. That means if two sides, okay, of one triangle are equal in ratios and one of the angle between them is equal, then also I can say that the triangles are similar, and that will be in SAS similarity test. The word similarity is very important to use, otherwise you will not be able to tell the teacher that whether you're talking about similarity or congruency. So keep that in mind. So AA similarity test, SSS similarity test, and SAS similarity test. Okay. Will A similarity test be considered? No, because the moment you say that two angles of one triangle are equal to two angles of the other triangle, you're done. You already have said that those two triangles are similar. Okay. Okay. Let us study one theorem, and the theorem says if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, the other two sides are divided in the same ratio. Okay, and it becomes difficult to understand, right? So let us keep it very simple by drawing a figure. Okay, so if a line is drawn parallel to one side of a triangle, so let us have one triangle first. Okay, so I have a triangle and let us name it NAF, N-A-F. Okay, now a line is drawn parallel to one side of the triangle. Can you imagine one line parallel to any side of this triangle? And I can be very sure that you are thinking about it as parallel to AF, right? I can read your mind right now. So let's do it. So I have a side which is parallel. Okay. Now this line which is parallel to AF is going and touching the other two sides at two distinct points. So to intersect other two sides at distinct points. So which are those distinct points? Those distinct points are nothing but P and point Q. So NA is one side where P is the point of intersection and NF is the other side where Q is the point of intersection. This is what the entire thing is telling you now. What is the result? What are we understanding from here? Okay, the other two sides are divided in the same ratio. So look at the slide properly again, and the ratios will be something like this. Okay, so NP upon PA, it will be equal to NQ upon QF. Now every time whenever you're seeing all these slides, you're looking at it in terms of very crude way of picturizing it, and as a mathematicians, we should not put it in this form. So let us give those letters, names, right? Those sides should have some name. So I can write NP upon PA is equal to NQ upon QF. Whatever I have shown it in that picture, you're looking at it in terms of the names of those sides. Again, so all I'm doing is I have a triangle and a line is drawn parallel to any side of the triangle, okay? Need not be only the base one. So it can be parallel to any side. Whenever it intersects, those other sides at two distinct points, those sides will be in the same ratio. This theorem was given by a mathematician by name Thales, and he told to everyone, and I'm telling it to you. But do you think, should I believe whatever is told? Will you believe like that blindly? I suppose you should not, because let's understand, let's prove it, and be confirmed that it is happening like this, So let's go ahead and, so converse is also true, So if someone tells us that that ratio is equal, then I should be sure enough to understand that there is a line which will be always parallel. So given D and E are points on the side of RS and RT respectively of triangle RST such that DE is parallel to ST, EM is perpendicular to RS and DN is perpendicular to RT, and DT and ES are joined, prove that RD upon DS is equal to RE upon ET. So much of information, and blindly when you just read it, it becomes very difficult to understand unless and until you have a figure. So here I have a triangle and D and E are points on RS and RT, right? So D and E are 2 points on triangle RST, such that DE is parallel to ST. So let's draw a line parallel. So DE is parallel to ST. EM is perpendicular to RS. Now M is not, the point is not shown over there, so let's draw that point M, and so I have EM perpendicular to RS, DN perpendicular to RT, okay, and DT and ES are joined together. So now this would become something like this, okay. Now what are we proving? We are supposed to prove that RD upon DS is equal to RE upon ET, okay. So look at that triangle which I have colored in yellow. So RDE is one triangle. Now I'm supposed, okay, we'll write area of this triangle. Area of this triangle would be half base into height. So area of triangle RDE is equal to half, base is RD, height is EM. So I'm sure everyone has able to understand that RD is the base and height is EM, okay. And what is it that is telling us about all this? Area of triangle formula, okay. Now next what we are going to do is, in the second step we will consider this triangle, that is DSE. Now area of triangle DSE will be half base into height, okay. Now in this case my base is DS and height is EM. EM, why EM now? EM is already outside the triangle, right? Then how am I considering that as the height? Okay, you must have seen, okay, in a construction site that, you know, the people usually use a string and some weight attached to it, right? And then if you want to find out the height, they will keep it at one point and then it's still hanging right down, right? So same way, when we are talking in terms of height, we are taking the highest point of the triangle, and you can consider that perpendicular symbol that is there is some kind of a weight. So it will be straight down, that's it, right? So irrespective of whether it is inside the triangle or outside the triangle, height can be considered that way, okay. So from the highest point, perpendicular base, okay. So area of triangle DSE will be half, base is DS, height is EM. Again, reason would be area of triangle. Now third step is very simple. All I am going to do is take the first step and the second step and divide them, okay. So just for your understanding, let us draw one imaginary line over there, okay, and after division it would be something like this. So the left hand side we can't cancel anything, and don't tell me that A and A will get cancelled, you know, E and E will get cancelled. That is not possible, right? So the entire triangle upon, we can't cancel them, right? So left hand side remains as it is. On the right hand side, half and half can be cancelled, okay. EM is common, so that also can be cancelled. So what we are left with is RD upon DS. Now from where did we get all this information? We got it from step number 1 and step number 2. So let us write that, okay. Once you are done with this, let us go and continue. So step number 4 will be again to consider the same triangle RDE, okay, and this time we are not going to take the base on this side, but we are going to take the base on the other side of the triangle. So my base is RE and height is DN, right? So for the triangle, the topmost point to the perpendicular base. So area of triangle RDE will be given by half RE into DN, okay. Reason, area of triangle. Let us take, for the fifth step, we will consider this triangle, that is DTE, okay. So area of triangle DTE will be, can you try and check what would be the base and the height? I'm sure you can, right? 2 seconds to think about it. 1, 2, done. Okay, so area of triangle ETD will be half ET multiplied by DN, okay, and area of triangle. Again, same way, what we have done in the third step, we are going to do for the sixth step. We are going to divide the fourth step and the fifth step. And you should be able to tell what should be the answer over there. It will be something like this. Okay, half and half will get cancelled, dn and dn will get cancelled. So what will remain is RE upon ET. And from which step? We got it from step number 4 and step number 5. Okay, now concentrate on the figure. I have selected two triangles over there, DSE and DTE. Okay, now these two triangles have equal areas. Now you'll wonder why equal areas. Okay, that is because if you remember your chapter in the 9th standard that you have studied about areas of parallelograms, there was one concept that you studied, that if a triangle is on the same base, so considering this as the base, okay, no, not this one, okay, the upper one, and the triangles are between the same parallels, then the areas of those two triangles are equal. So based on that, I can write the 7th step. Okay, that is area of triangle DSE is equal to area of triangle ETD. Okay, reason would be whatever I have told you. So triangles on the same base and between the same parallels are equal. Okay, so triangles on the same base and between the same parallels. Now, if this is equal, all I can do is wherever that triangle, area of triangle ETD is there, all I can do is replace it with DSE. So instead of this ETD, I can write this as DSE. Okay, and when I do that, which step am I substituting it? I'm substituting it in the 6th step because ETD was there, right? So instead of ETD, I will write DSE, and then the entire step number 6 is written back again. Okay, so I've written step number 6 exactly as it is. All I've done is changed that denominator to DSE because in the previous step it was equal. So which are the steps that I have used, to come up to this conclusion? I have used step number 6 and step number 7. Okay, so based on this, I have come to this conclusion for step number 8. Now look at the step number 3 and step number 8. The left hand side are equal, isn't it? So if the left hand sides are equal, the right hand side will also be equal, and therefore I get to a point where I can say RD upon DS is equal to RE upon ET, and this is from step number 3 and step number 8. Okay, and that is what we are asked to prove, and we are done with it. So in case you want, you're feeling shy to get in touch with me and you want this proof right away, you can take a screenshot of this and you're done, or take a photograph. Okay, so the entire proof is over here. You can copy them later, but concentrate on the understanding part. Now next, what I would want from your side is that please do not by heart this entire proof, because I've come across so many students that they just by heart it. Okay, they will keep on writing with different alphabets and this and that, but just by heart the entire proof. I don't want you to do that. Now then how do I learn the entire proof? All I have to do is chunk all those steps in a bits. So what will happen is, first when I started with the entire proof, I started with the first triangle which is on top, right? So all I have to do is talk about the areas of those triangles. Then I will look at it in terms of a triangle and two other triangles which are like the legs of it, right? So first triangle, the head, then the other triangle, areas that I'm going to take, divide them, and I will come to till step number 3. Then again I go back to the head, the big triangle, and then the other side of the triangle, right? So that will be my next step. So step 4 and 5 will be over there. Step 6 is nothing but division of those two steps. This 7th step is a completely different concept over there. So you need to keep in mind that those two legs of two triangles are equal, and why? Because they are on the same base and between the same parallels. Once they are equal, I can just equate it to the other steps, and then you are done. And it's that simple. So whatever Thales, the mathematician, said is proved, and I hope you have understood this entire proof. Alright, so let us study another theorem which says that the ratios of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. Again, without the figure, it would be very difficult to understand, right? So let's draw a figure. The ratio of the areas of two similar triangles. So two triangles are similar. We have already discussed how triangles can be similar. They can be either similar by AA similarity test, side similarity test, or SAS similarity test. Okay, so we are not discussing how they are similar, but we will consider that they are similar. So what is happening? The ratio of the areas. So again, ratio means numerator upon denominator. That is for you to understand. Okay, so here I have two triangles, one in blue and okay, it's purple, and the other one in red. Okay, so they are in the ratio. That means there should be a numerator upon denominator for it, right? Now this is equal to what? It is equal to the ratio of their corresponding sides. So my ratio would be something like this. No, is it just equal to the ratio of their corresponding sides? No, it is equal to the square of that ratio. So all I have to do is square this. So I hope the theorem is clear. So if there are two triangles, okay, which are similar, then the ratio of their areas will be equal to the corresponding sides, but square of those corresponding sides. So mathematically, if you want to write this entire statement, then it would be something like this. Now I'm not given the names of those triangles, so just understand that area of triangle NQS, which is in the numerator, upon area of triangle MPL, which is in the denominator. Okay, and QS is one side of the triangle and PL is the other side. So I take those corresponding sides, and whatever answer that I get, I square it. Now that will be equal. Now what exactly it is trying to tell us? So just for an example, okay, I take NQS, some value of that triangle, right, area, put it on the calculator and divide it by the area of the other triangle. After dividing, say if the numbers are very complicated, I might get some numbers in decimals. Okay, now that answer is equal to what? It is equal, I take two corresponding sides of those triangles, divide them on the calculator and square that answer. Now that answer which you got after squaring and the ratio of these areas, they are equal. That is what the entire theorem tries to tell us. Okay, so let us try and prove this. Okay, so triangle NQS is similar to triangle MPL. NT is perpendicular to QS such that QTS and MD is perpendicular to PL such that PDL. Okay, let us draw a figure. So there are two triangles, right? NQS and MPL. Now NT is perpendicular to QS such that QTS, most of the times, whenever this thing is told QTS with dashes over there, students don't understand what exactly means over there, and then they write anything. It only means that T is in the middle of QS. Okay, that's the only information, because sometimes you can have a perpendicular, height. I told you in the previous proof that it can be outside the triangle. In this case, it is not that way. It is telling you that T is in between Q and S. Then next is MD is perpendicular to PL such that PDL, that means D is in between P and L. then if this condition is satisfied, this is given to us, you are supposed to prove that area of triangle NQS upon area of triangle MPL is equal to square of their corresponding sides. Now, in the previous class that or previous slides that we have studied, we have realized that corresponding sides, 3 corresponding sides, right, of one triangle to the other triangle. So, is it compulsory that you have to take only one pair, one side of the corresponding? No, it can be for all the sides, right? So that's the reason I have 3 different sides in the ratios. Okay. Now, to prove this, okay, before I prove, I have just marked these 2 angles, QN, angle P over there, which is not given in the question at all. But you need to learn, or you need to remember, that angle Q and angle P are equal. Why? Is because we have already told that triangle NQS is similar to triangle MPL. So when 2 triangles are similar, the corresponding angles are equal. So here QN angle P is equal. Okay, remember this because we will require it to continue when we are proving it. Okay, so the same figure is redone again, and now this triangle NQS, area of this triangle can be written as half base into height. So I'm sure everyone will be able to understand this. Base is QS and height is NT, half base into height, right? So let us write that in the statement. So first thing that we have to write is area of triangle NQS is nothing but half QS into NT. Okay, and reason would be area of triangle. Second is this triangle, that is MPL. Okay, so area of triangle MPL will be half base into height again. So base is PL, height is MD. Okay, there you can see the change in color, and it would become area of triangle MPL is equal to half PL into MD. Reason is area of triangle. Okay. Now, third step is nothing but taking the first and the second step and dividing it in the ratio. So, by now you already, you can able to understand how to divide this entire thing. So, it would become half and half will get cancelled. I can't cancel QS and PL, so it will remain as it is, and NT upon MD will also remain as it is. Okay. From where did I get all this information? From step number 1 and step number 2. So let us write that. Okay. Now, next thing what we are going to do is we are going to look at these 2 triangles, NQT, which is the orange colored triangle over here, and MDP, which is part of the other triangle. Okay. Now, in these 2 triangles, angle Q is equal to angle P. I had already told you in the previous slide, keep this thing in mind. So that is what we have. So angle Q is equal to angle P. And why did I tell it was equal? It was equal because the entire triangle NQS and MPL are similar. So angle Q is equal to angle P, given that NQS is similar to triangle MPL. Okay. Now, next step, I can write that we were told that NT is perpendicular to QS, right? So perpendicular means the angle is 90 degrees. Same way MD was perpendicular to PL, so angle D is 90 degrees. So I have written that. Okay. With statements it would become angle NTQ is equal to angle MDP. Okay. And reason would be what have I told? So NT is perpendicular to QS and MD is perpendicular to PL. Okay. Now, based on these 2 the steps, right, the 4th one and the 5th one, where angles, 2 angles of one triangle are equal to 2 angles of the other triangle, I can say that triangle NTQ is similar to triangle MDP by AA similarity test. Okay. Now, a very important thing to keep in mind when you are writing triangles similar is that you need to make sure that the corresponding angles from where you started are exactly written as it is. Now, what do I mean by this? Now, take for example, triangle which is in orange color, that is NTQ. Now, you have learned in all your lower classes that I can name this triangle in three different ways. I can start by saying triangle NTQ. I can also say it as TQN. I can also say it as QNT, right? And it's fairly correct. There is nothing wrong over here. But when you are comparing it or trying to say that one triangle is similar to the other triangle, you need to keep in mind that you go in the same order. Okay. So I'm starting from angle N. Okay, the point N which is there, which is the topmost point. Same way for the other triangle, I'm starting from M, which is the topmost point. Then I move to angle which is 90 degrees, which is T, and for the other triangle I move down to D, and then the angle Q and angle P. So this order is very important. So is it compulsory that you have to start from the highest point only? No, but you can start it, keep the same direction, right? So it is like, say you were trying to eat food, right? It is not that I will eat one with one spoon and then suddenly start eating like this. So there is a certain order that you follow, right? So keep that thing in mind. So NTQ and MDP. Okay, so these two triangles are similar. So once these triangles are similar, I can write the corresponding sides. Now, when it comes to writing the corresponding sides, most of the students make mistakes over here. Okay, and because of which I'll just quickly tell you how you have to write it down. So once you have written the ratios properly, look at the mouse pointer. Okay, so here this would become NT upon MD and NQ upon MP. Okay, it is that simple. So NT upon MD and NQ upon MP. Then only I can write the similar corresponding sides in the ratio. Okay. Now, in case you still have confusion with this, where I can understand most of you will have, but you can just go on to my channel. There's a video that I've put up with regards to this. Okay, how the ratios have to be written. So you can check that out. So here there's a new word that you are understanding, that is CPST. It only means that corresponding parts of similar triangles. In the previous class, in the 9th standard, you have studied about CPCT, right? That is corresponding parts of congruent triangles. This is nothing but corresponding parts of similar triangles. So sometimes students write the ratios and write CPCT because of the practice. So that is incorrect. You can't write CPCT over there. You have to write it as CPST, that is corresponding parts of similar triangles. Okay. Then next is I have written QS upon PL is equal to NQ upon MP. Now here, from where did I get this? Look at this triangle. So QS, right? So QS is over here, this part, upon PL, and NQ upon MP. These are nothing but sides of triangle NQS and MPL. So because these triangles are similar, I'm writing this statement. Okay, so this would become, given NQS is similar to triangle MPL. Okay. Now, if you look carefully, in the 7th and the 8th step, the right hand side are same, right? They're equal. So if the right hand side are same, I can write the left hand side also to be equal. So this would become QS upon PL, okay, which is of step number 8, and NT upon MD, which is of step number 7. Okay, so I got this entire information from step number 7 and 8. That's the reason I have written it from there. Okay, next look at this, nt upon md is equal to something somewhere, right? And that is, look at step number 3 now. If you notice that there is nt upon md over here, so instead of writing this, because it is nt upon md is equal to qs upon pl, I can just replace nt upon md with qs upon pl over here. So all I will do is, in the 10th step, I will write this step number 3 again, but all I will change is this nt upon md, okay, and you get qs upon pl now. And it is from which 2 steps? I have taken into consideration step number 3 and step number 9, and qs multiplied by qs will become qs square, and pl multiplied by pl will become pl square. So this part is done till here, and I can write the word similarly and say the other sides will also be in the same ratio. I hope this entire proof is very clear. How do we remember? Very simple. Consider first the entire triangle, write area of triangle for those 2 triangles. Then consider any one of the triangle, either left hand side or right hand side, okay? So if you're considering the first one as left, second one also has to be the same one, okay? Prove them similar and write their ratios, the ratios of the big triangles, and just equate them. It's that simple. So please do not by heart the proof, because if you by heart, trust me, by the time you're going to answer your exams, these proofs will be just waved off from your mind. So don't by heart them, learn how to remember. So all I would say, if you take this presentation from me, then you can print it out or write it down and write outside the margin what are the things that you are actually doing. Okay, don't copy the entire proof, but write what are the steps taken to come to this conclusion. Okay, so I hope the entire proof is clear.